Hello and welcome to the channel. In this series of videos called Corporate Finance, I'm going to show you the solutions of end of chapter problems by using Excel as a calculation tool. As you've seen from the video image, course of Corporate Finance is taken from the Wharton School of Business. Why Wharton? Because Wharton is known as the best business school in the world. So let's get knowledge from the bests. I took the course syllabus from the official website of Wharton for undergrads. So there is a book mentioned of Corporate Finance of 12th edition from the authors of Ross, Westerfield, Jeffy and Jordan. In my case, I have only bought 11th edition, but basically there are no big differences between 12th and 11th. Before I start, let me introduce myself a little bit. My name is Dorian Tenelbayev and I'm from Kazakhstan. Currently, I'm a third year student and my major is corporate finance and investments. With that all, I will begin from the first topic in a syllabus, which is discounted cash flow valuation. So let's get started. I start from the basic part. Questions in a basic part are really easy to solve. For example, in the first task, we have to calculate the present value. So we have our inputs here. All we need to do is to enter our inputs to the formula. I use the formula of PV, which stands for present value. And for discount rate, I select this cell. And for number of periods, I select this cell. PMT, regular payments, I don't have it in this case. That's why I just skip it. And I will use the negative future value in order to end up with the positive present value. Close the bracket, press enter, and with the shift key, I select these cells and click Ctrl D buttons together, and my formula is copied down here with all inputs changed, as you can see. Moving to the second question, we have to calculate the interest rate. We use the formula for rate, number of periods 4 years, this cell. We don't have PMT again, skip it. And for present value and future value. Let's put it in this way. For example, someone gave this amount of money to the bank 4 years ago. And from the perspective of a person, it was a negative cash flow. So that's why we use negative sign for present value. And after 4 years, this person will receive the money with interest from the bank. And again, from the perspective of a person, it will be positive cash flow. That's why we use positive future value. Copy formula, and here we are. We will end up with correct results. Calculating number of periods, really use NPER formula, which stands for number of periods. Select rate, and we don't have PMTs, skip it. Negative PV and positive future value. And here we are. We will end up with just number of years. Moving to the next question, calculating effective annual rate. So we have two banks. They have different rates, and the compounding frequency is different. So National Bank compounds its interest monthly, and United Bank compounds its interest rate semi-annually. So we will use this formula now to calculate the effective annual rate. So we have 1 plus, in our case, just rate, it's the annual rate, which stands for APR. We just divide it to the compounding number and select in the power of 12 and minus 1. If we convert it to the percentage, it would be 10.8. And copy the formula to the right side. So we will use Control R button together, and our formula is given right here. I think someone is wrong here. Something went wrong here. 84%, it's really huge number. Yeah, it's compounding period is 2 here. And here we are. So question was, as a potential borrower, to which bank would you go for a new loan? So obviously we will choose the United Bank. So it offers less effective annual rate, which means we will pay less interest in the case of borrowing money from the United Bank. And last question, and a basic part here. So you can pause the video not to read the conditions for the task. But here is a question. We have to calculate the first present value and then discount rate per week. After that, we will we will calculate the annual rate, and finally we will end up with effective annual rate. So we have to check whether the condition is correct or incorrect. So as given in the text, our PV, which is 12 multiplied 12 months multiplied by $10 per each bottle, price per each bottle, and 1 minus 10%, which is discount. So final PV is $108. So we have to calculate the rate. We use the formula for rate. Number of periods is 12 months, and PMT, which is given in the text, is $10. We use negative PV, and then we don't have feature value. And for the type, we will use the beginning of the period, which stands for annuity due, not ordinary annuity, but annuity due. So that's the rate for 1 week. So in order to have the annual percentage rate, we multiply this by 52, the number of months in 1 year. We will convert the present value or a percentage, and we will end up with 102. So again, we will use the formula of effective annual rate. One plus this percentage rate in the power of 52 minus 1. If we will convert this into percentage value, the author was correct in his calculations. So basically, if we'll round it, it will be 177%. So that's all for basic part. Now let's solve some questions from the intermediate part. For the first task, we have our initial salary, and the annual growth rate is 3.7%, and we are willing to deposit 5% of each annual salary on the account that earns 9% per year. So the question is, what will be the future value of that account after 40 years? As its name says, we are dealing with growing annuity here. So this is a special formula, and we will use it in order to calculate the present value of growing annuity. So let's get started. First of all, we have to find out the next year's salary, which is initial salary multiplied 1 plus growth rate. And we will deposit the 5% of it. So the first deposit is considered as first PMT. So we'll use it as our input for the formula. For the convenience, I have divided this formula into two parts. So the first part is PMT. In the denominator, we have return rate minus growth rate. Oh, sorry. Choose this cell. And here we are. And for the second part, 1 minus open two brackets, 1 plus growth rate, divided by 1 plus return rate. Finally, in the power of 40. And we multiply our results, and here we are. The total PV is 61,000. And we were asked to calculate the future value. We'll use the formula of FV. Again, return rate is 9, NPR is 40, PMT and minus PV. And finally, we will end up with $1,924,000 on that account after 40 years. Moving to the second question, we have our table here. This table, we have number of years and cash flow for each year. I'm so sorry. And for the second year, we are missing the cash flow. So we have to calculate it. As given in the text, the total PV for all cash flows is 7,300. We will use a formula for PV, and our rate is 7.1%, and we will lock it by clicking the F4 key, because we will use this rate as input for all cash flows. It will not change. NPR is each year, PMT, and minus future value. Copy formula. We are missing the second year cash flow, and for now we assign the value of 0. And by clicking Alt equal sign together, the formula of sum shows up. It's really convenient. Click Control Enter, and here we are. The total PV without the second year cash flow is this amount, 5,800. All we have to do is now subtract total PV from which we have calculated. So now we have to do the inverse calculation. This is our PV, and we need future value. That's why formula of FV rate is 7.1%, NPR is 2, and with minus present value. And here we are. The answer is 1,717. We are now in challenge part, calculating annuity values. This task is about Bilbo Baggins and his retirement. You can pause the video and read it yourself. So, here's the timeline. Those are months and those are cash flows. Since the cash flows occur monthly, we must get effective monthly rate. One way to do this is to find the APR based on monthly compounding and then divide it by 12. We will use this formula in order to convert our effective annual rate to APR. So let's get started. Equal sign 12, which means months multiplied by open two brackets 1 plus effective annual rate in the power of 1 divided by 12, and then minus 1. Those are our annual rates, and then we just simply divide it by 12. We have found our pre-retirement and after-retirement monthly rates. Next, how much he needs at retirement. The amount needed at retirement is the present value of the monthly spending and the present value of the inheritance. We use a formula for present value, and then as a rate, we will use after retirement monthly rate. NPER here is 600 minus 360, and our regular payment is negative 20,000. So we use negative sign not to have positive present value. And for the inheritance, we just it's just a lump sum. That's why we use our annual measures. Again, formula for PV: rate is 8%, NPER is 20, as it is given in the text. Then we don't have payments, and then negative 1,500,000. This is the amount of inheritance. So actually, at retirement, he needs 2,763,000. So he will be saving 2,100 per month for the next 10 years until he purchases a cabin. The value of his savings will be future value. Rate is pre-retirement monthly rate. NPER is 120. And the PMT is 2,100. The cost of cabin is 350,000. The left amount is just we simply subtract is this amount. He still has 20 years until the retirement. When he's ready to retire, the left amount will have grown to this future value. Our rate is, again, pre-retirement monthly rate. NPER is 360 minus 120. Then PMT, we don't have it, and the negative present value. And actually the needed amount, we just subtract total PV now minus the future value of left amount. Basically, that's finally we use the formula for PMT. We use again rate of pre-retirement monthly rate, NPER again 360 minus 120. PV, we don't have it, and the future value should be 2 millions. And here we are. Basically, Bilbo Baggins should save almost 2,500 each month from year 10 through 30 in order to meet all his 3 objectives. Moving to the second question of challenge part, future value and multiple cash flows. An insurance company is offering a new policy to its customers. Typically, the policy is bought by a parent or grandparent for a child, the child's birth. So we have our birthdays here and relevant cash flows here. So after the child's 6th birthday, no more payments are made. But when the child reaches age 65, he or she receives 250,000. If the relevant interest rate is 11% for the first 6 years and the 7% for all subsequent years, is the policy worth buying? We need to find the future value of the premiums to compare with the cash payment promised at age 65. We have to find the value of the premiums at year 6 first, since the interest rate changes at that time. So that's why we use the formula for future value, and the rate is 11%, and we will lock it by clicking the F4 key. And the NPER is different for each cash flow. So for example, for the first cash flow, we write it like 6 minus 1. So it means the first cash flow will be compounded 5 times, and the second cash flow will be compounded 4 times. We don't have PMT and the negative present value. That's why we copy the formula down. And finally, we sum it up. Let me just highlight it. So our future value of that cash flows is equal to the almost $5,000. And the next question is, we have to find the future value of that lump sum amount that we have calculated. Again, we will use the formula for future value here, and for this case, the rate is 7%. NPER is 65 minus 6. Then we don't have PMT, and the negative present value, 4,904. So the policy is not worth buying. The future value of the policy is $265,000, but the policy contract will pay off $250,000. The premiums are worth $15,000, more than the policy payoff. We're now on the third task, annuity present values and effective rates. You can pause the video and read it yourself, but the main numbers are given here. So we receive 4,500,000 from the lottery today, and we are going to receive 40 payments of 1,600,000, and the investment fund is offering 30 million for our lottery, and APR is 9%, and it is compounded daily. Since the payments occur at 6 months intervals, we need to get the effective 6 months interest rate. We can calculate the daily interest rate since we have an APR compounded daily. So our daily interest rate is 9% divided by 360. And our effective 6 months interest rate is, so equal open brackets 1 plus our daily rate in a power of 180 minus 1. And 4.6. And then we can use the present value of annuity equation to find the present value of the semi-annual payments. So we will use the formula for present value, and rate is 4.6. NPR is 40 as it is given in the text, and our EMT is 1,600,000. This is the value 6 months from today, which is one period, 6 months prior to the first payment. So the value today is present value. Again, our rate is 4.6, yeah. NPR is just 1. We don't have PMT. Our present value is, we have calculated here. And here we are. The total value of that, total value of the money that we will receive today is our present value and 4,500,000. So we should not take the offer since the value of the offer is less than the present value of the payments.